Hello, and today we're going to learn how to use the law of cosines. This should follow how to use the law of sines, which is a different strategy for solving for pieces of a triangle. Law of cosines is a little bit more complicated, and it's an equation, but there is an upside to it that the law of sines does not have. So first, let's take a look at what it is. For our triangle, where we label the vertices with capital letters and the opposite side lengths with the lowercase letters, so notice that side C is across from angle C, side A is across from angle A. The law of cosine states that the square of any side length is equal to the sum of the squares of the other sides minus twice their product times the cosine of the opposite angle. So the big thing to notice here is notice that these guys right here correspond with the c squared that's isolated and the angle that's on the inside of the cosine function. So, and you'll kind of see me do this. I'll try to link up what is the opposite angle and opposite side that we're using. Notice c is the only angle used in the law of cosines. There's no second angle or third angle. It's all just angle c. So it being the only angle in there becomes important what we call C, quote unquote, and therefore what we call the side length opposite of C. So when do we use the law of cosines to solve for pieces of triangles? Well, if you know a corresponding side angle side, and you're looking for the third measurement to the third side of the angle, then the third side of the triangle, then that's when you would one of the instances you would use it. The second instance is if you know all of the side lengths, you know no information about angles, and you're trying to find out what one of the angle measurements were. So we're going to look at one of each of these cases today. All right, first we have a triangle that we know two side lengths and the angle in between, which is a side angle side configuration, and we're looking for the third side. Okay, so what I said before was that it's going to become very important the angle that we're using and the side length we're solving for. So this is that side length opposite angle combination. So that's what we're going to have to really pay attention to when we're setting up our equation. That isolated side length across from the angle is what gets squared and isolated from the rest of everything. Okay, these two are interchangeable. It doesn't matter necessarily what order you put them in, because you're just going to add them, which is commutative, and then you're going to multiply them, which again is commutative, so it doesn't matter. And then we're going to multiply that times the cosine of 100 degrees. Okay, and we actually do know the value of a and b. I just put in a and b, but we know that this is 4 and 9, so 2 times 4 times 9. Okay, everything on here, there's no variables on this side of the equation, so you can just go ahead and plug this right into your graphing calculator or your regular calculator if you have one that does sine and cosine, and just see what you end up getting. So you end up getting approximately 109.5. Okay, and the last step is to square root both sides. X being the side length of a triangle, it's got to be positive, so we just want the positive value. So when we take the square root of 109.5, we end up getting 10.46. So that missing side length of the triangle is 10.46 feet. Kind of makes sense because it's across from what has to be the biggest angle in the triangle, therefore this has to be the biggest side length, so 10.46 is. And it does adhere to the law that states that the sum of any two side lengths of a triangle has to be bigger than the third. So that works. Alright, let's look at that second case where we would use the law of cosines. Here we have every single side length and we're looking for one of the angles. Alright, again, this angle and the opposite side length is a very important pair, so we're going to use that to write our equation. That side length that's isolated is what is squared and isolated in the equation. So 16 squared is equal to, again, these are interchangeable, so 5 squared plus 14 squared minus 2 times 5 times 14 times the cosine of x. Alrighty. Now what I would do here is I would immediately subtract 5 squared and 14 squared from 16 squared. And the reason I would do that is because some students get in a bad habit of combining all of these numbers together in their calculator. But this is a coefficient of cosine of x, and this is not a coefficient. So coefficient, not coefficient. You can't combine them. So what I would immediately just subtract the 5 squared and the 14 squared from both sides. And I'd end up with this. It's not necessary to do it this way, but I just think it saves students the trouble of making one of those mistakes of just combining all these numbers together, because this is addition and then this is multiplication, so this is tied to the cosine of x or multiplication. You can't do anything else with it. Alrighty, so if you plug this into your calculator, 16 squared minus 5 squared minus 14 squared, you'll get 89. So 89 is equal to, if you plug this into your calculator, you're going to end up getting a negative 140 cosine of x. Alright, let's see, we're trying to isolate the x, so let's first divide out that negative 140. So we get negative 89 divided by 140 is equal to cosine of x. Alright, now this is one of the benefits of using the law of cosines as opposed to the law of sines for finding an angle measurement. Here we're going to have to solve for x, which means we're going to have to use inverse trig. Inverse trig, though, is defined for cosine just between 0 and 180. Well, the good news is that every single angle in a triangle has to be between 0 and 180. So when you use inverse cosine to solve for x, the value that you get is the value that you get. You don't have to worry about an ambiguous case or there being two solutions, one solution, no solutions. It actually always ends up working out based on the nature of the triangle that's given to you, as long as what you're given is a real triangle. In this case, it is. The sum of any two side lengths here is bigger than the remaining third side. So in this case, we don't have to worry about any ambiguous case. We can, very confidently just take the inverse cosine of negative 89 over 140, and that's going to be equal to x. So if you plug that into your calculator, you'll end up getting that x is approximately 129.5 degrees. So there's one of the benefits of the law of cosines, is you don't have to worry about the ambiguous case. If you have three side lengths, you have to make sure that it's a real triangle, that it's not an impossible triangle. But you never have to worry about an ambiguous case when you're using inverse cosine. You don't have to worry about anything there. Everything is already set for you because of the way that inverse cosine is defined. Alrighty, that is the law of cosines.